Hi kids, I have prepared some videos on vector addition very scrupulously. Have you gone through that?
Yeah, we have gone through a few of them. The first video was interesting and the others were okay. I think we need to explain it in more interesting way.
How will that be possible?
Yes, we have an idea. We have come with a bunch of practical funny questions. If you use them, I'm sure that people will grasp better.
Well, so what are your questions? Can you give me your first question?
What is displacement? Why is displacement a vector? And why distance is a scalar?
Oh well, is there any other question?
Yeah.
Please tell me.
How can displacement be zero even when distance is not zero?
Well, it's interesting. Okay kids, do you have any other funny questions?
Sir, we have another doubt regarding vector addition. We know that 2 potatoes plus 3 onions equal to 5 potatoes plus onions. What will happen if we add 2 Newton of force plus 3 meter of displacement?
Well, it's interesting. Yeah, of course I am very happy that you are asking very interesting questions. I hope you have come with some other questions.
Yes, sir. Sir, in your previous video, you have talked about triangle of addition.
Yeah.
Now, if I have a triangle and 3 vectors are passing in a triangle, like from A to B, B to C, and C to A, what is the resultant? Is it 0?
Oh, it's a very funny questions. Well, my dear kids, let me try to answer these questions you have posed. These questions are very interesting, especially very fundamental questions, even though I have discussed some of these questions in my last videos. Let me recapitulate all this. The first question is about the character of distance and displacement. Distance and displacement. Even though these two things will be discussed in the chapter of kinematics, but without referring to distance and displacement, we cannot start the vector and the vector addition, because for vector addition, the displacement vector is the fundamental entity. It's a fundamental factor to start vector operation, the subtraction, the addition and subtraction of vectors. Displacement is a vector quantity, but distance is a scalar quantity. By distance of 5 meter means is no direction. By the displacement of 5 meter towards east, this is the displacement. We can write 5 is the magnitude and towards east is the I cap direction. This is east, this is west, this is north, and this is south. So each direction is given by the unit vector I cap. 5 meter towards east is different from just 5 meter distance. So distance of 5 meter is no direction part is there. It may be the straight distance from here to here, A to B. It may be in a curve. The curve distance is the straight distance. So this is the length of the path. The distance is the length distance is length of the path. But displacement is different. But displacement from suppose A to B is the starting point, or you can say initial point, and B is the final point or destination. You are moving from A to B. In many paths you can do that. In many paths you can move from A to B. Countless paths, innumerable paths you can move from A to B. Path 1 to n number of paths, countless paths. However, your result is same. What is the result? To get the point, final point B from A to B. So the straight line distance, so the shortest distance between the initial and final position, initial and final point, and given an arrow towards the final point. This is correct, but this is wrong. This is correct. The arrow should be given at the end of the segment. Then this is the correct geometrical or graphical representation of the displacement. But if you put the arrow in the mid, it's the wrong representation. So this is the displacement. It is, we can say in different way, that when you observe the point B, the final point from the initial point, this is the position vector of the final position with respect to the initial position. So displacement is nothing but position of the destination or the final position with respect to the initial position. And since, as I explained in my first video, if you ask a baby, where is the point B? When the baby is standing at the point A, the baby will point his finger towards B. So the position of the B with respect to A can be explained by pointing the finger. Therefore, the vector AB, or the position of B with respect to A, is a vector quantity. That is what is numerically equal to the displacement. So displacement is the first fundamental vector quantity. After the position vector, of course, displacement is nothing but the position vector of the final position with respect to initial position. So basically the question was between displacement and distance. Displacement is a vector quantity, whereas distance is a scalar quantity. Displacement has direction and distance has no direction. Between any two points, there can be many distances. There can be many distances. These are all different lengths. Length 1, length 2. There can be many distances. But the displacement is one. It is pointing from the initial position to the final position and directed in this way. And if you put the tip at the end of the segment, really the point, the tip of the marker moves from A to B in different paths. However, even though it may not move in this way, but always the straight line between A and B, the straight line segment AB, having an arrow at the point B in this way, represents This vector quantity, display लिख दीजिए.
नहीं कर.
Let's talk about the second question. The second question is, why should a distance not be zero in general, whereas a displacement of a moving object can be zero. Why can a distance not be zero, whereas the displacement of a moving object be zero? This is the question. Second question. For this, let me take a simple example. There are 2 points, point A and point B, starting point, ending point. You can move in many different paths. You can move in this way. You can move in this way. You can move in this way. Path 1, path 2, path 3. These are the distances. When you are moving between 2 points, the length of the paths cannot be zero. It is quite clear, you can see this. When the tip moves from A to B, the lengths cannot be zero. L1 is not equal to L2, is not equal to L3. In general, is not equal to zero. How we can say this? However, the distances means the length of the path covered cannot be zero, whereas the shortest path can be zero. How? If you imagine the initial point and the final point, initial position and the final position at the same place, then you can move in this way, you can move in this way. The length cannot be zero. However, the shortest distance between these 2 points, when these 2 points coincide, can be zero. And the shortest distance is nothing but displacement. The shortest distance between these 2 points is nothing but displacement. We can say the displacement in this case is nothing but AB. Can be zero, can be zero. It's a zero factor, it's not simple zero. It's not a zero scalar, it's a zero factor. When A coincides with B, the initial and final positions, the starting point and the destination, they coincide. I mean, the point, moving point, or the object or the particle comes back to its original position. In that case, the displacement can be zero. However, distance can never be zero for a moving object. Now this, I think this answers your question. Interestingly, the third question you have posed regarding the addition of scalars and vectors. The basic question. You have taken 2 potatoes and 3 onions. You are adding, mixing it up. They don't lose their identities. And you are getting the total number of particles is 5. and it is a mixture of onions and potatoes. So the scalars you can add in this way. 2 liters of milk and 3 liters of water, when you add, you are getting 5 liters of the mixture of milk and water. It is totally practical. Day-to-day life we experience these two examples. So 2 plus 3 is equal to 5. 2 of x, 3 of y is equal to 5 of x plus y. 5 of x plus y means the mixture of x and y. It means like that. X plus y I wrote in that sense. But 2x plus 3y is not equal to 5 into x plus y. It doesn't make any sense in that way. 2 articles or 2 numbers of x quantity plus 3 numbers of y quantity is equal to 5 numbers of the mixture of x and y. It means that. Whereas 2 meter displacement plus 3 Newton force, suppose. If you add these two vectors, it is a vector, suppose A, this is a vector B. If you add it, what does it mean? This is the question you have posed. And the straight answer is that you cannot add two vectors of different varieties. You cannot add the displacement with force, force with velocity, displacement with velocity. Two different types of vectors you cannot add. So in that way, A vector plus B vector, when these two vectors are don't belong to a particular quality of vector or particular types of vector, when you add them or subtract them, it doesn't make any sense. So A plus B is meaningless. Is meaningless. This is the answer. So from your third question, we have understood that different types of vectors such as force plus velocity plus displacement, it doesn't make any sense. So similar type of vectors can be added. Force can be added with force. Displacement can be added with another displacement, and the velocity can be added with another velocity vector. Based upon this concept of addition of similar type of vectors, you have put the fourth question, that in the triangle law, suppose you take a triangle ABC, A, B, C, and you have stated that one vector, suppose this is a force vector. The force vector F1 is pointing along AB from A to B. Another force vector, say F2 vector, is pointing from B to C, and the third vector, F3 vector, it points along C from C to A in this way. these factors, if three factors, needless to mention, similar type of factor means force vector or velocity vector or displacement vector. If three vectors F1, F2 and F3 point from A to B, from B to C and C to A. In the triangle ABC, the fourth question you have posed, then can the addition of these three vectors be zero? This is the question. Well, if you think that the triangle law statement, the first glance many students may tend to write zero, but it is not zero, is the wrong answer. So the answer is no. It's very strange. Why it is so? To explain this, we have to go to the basic statement of the triangle of vectors, which states that when these vectors F1, F2 and F3 are represented by the sides of a triangle, if the vectors are represented by the sides of a triangle, then in cyclic way, of course in cyclic way, then F1 plus F2 plus F3 will be equal to 0. But here, these vectors point from A to B, B to C, C to A. They are just passing through the sides AB, BC and CA, but they are not represented by the sides. Now a question arises. When this statement is correct and this is wrong, what is the basic difference? The basic difference is, here in this case you have asked the sides of the triangle do not represent the vectors F1, F2 and F3. They are just passing through the sides. Then in this case, F1 plus F2 plus F3 cannot be equal to the zero vector. Now we may ask question, how can a triangle represent these forces? If you take the triangle A, B and C, if you ask that these forces not only point from A to B, B to C and C to A, but also the sides represent the forces, then the diagram would be in this way. This is the force F1. The tip should be in this way. The tip of the arrow cannot be in between, because the side AB represents the force F1. That means the tip will be here. Tip will be at B, and the tip of the vector F2 will be at the point C, and tip of the vector F3 will be at the point A. In this case, the sum of these three vectors will be equal to 0. It may be force, it may be velocity, it may be displacement, but displacement thing will be different. When you say displacement, then A to B, B to C, C to A. Displacement, if you take, instead of force, if you take a specific example of the vector as displacement, then you can write AB plus BC plus CA, because these are displacement. S1 plus S2 plus S3 is equal to 0. It's correct. Always this is 0. The displacements are nothing but the sides, but for any other vectors, in general, if you put the question in this way, that F1, F2 and F3, they just point along the sides of a triangle, but they are not represented by the sides of a triangle. Then some of these three vectors, when they are pointing or they are passing through the sides in cyclic way, some of these three vectors may not be equal to 0. But in this case, the vectors are represented by the sides of a triangle. Specifically, if you ask this question, then it will satisfy the statement of the triangle of vectors. According to that, the sum of these three vectors will be equal to 0. I hope this answers your question.